Okay, Algebra 1. This is section 6.6. We're solving absolute value inequalities. And the essential question that we're going to try and answer today is how do we solve absolute value inequalities? So I'll give you a second to get the page. Okay, here we go. Let's begin by saying what are absolute value inequalities? Well, we started off before and we had something like this. The absolute value of x was equal to 2. Now this is an equation because there's an equal sign here. This is not an inequality, but this is where we're going to start. So what we did before was we looked at the number line and we said, okay, well, if this is 0 here and 2 is over to the right and negative 2 is over to the left, then we said, okay, the distance from 0 had to be 2 units. So this is 2 units away. And this is all review, and this should sound familiar to you. So this is 2 units away. So we realized that there were 2 spots that were at an absolute value of 2 from 0, namely negative 2 and positive 2. So the answer was, well, x could either be 2 or x could either be negative 2, one of those two things. But what does it mean when we talk about this? The absolute value of x is less than 2. Or we could say less than or equal to 2. Well, that's different. Now, this is different because we have an inequality sign, right? This is the inequality sign. It says absolute value of x is less than 2. This is an absolute value inequality. So what we're going to do is we're going to examine this sort of the same way. We're going to draw our number line here. And we're going to say, okay, this is 0. All right, this has to be 2. And this has to be negative 2. And we want all values of x that are less than 2 units away than 0. Well, this is going to create a whole bunch of them. I can think of a couple of numbers that are whose absolute value is less than 2 units away. So what we do is we say, okay, well, I know that there has to be 2 answers just like there was before. So I know that I'm going to have this point in question, 2, and this point in question, negative 2, or reverse that, negative 2 and 2. And I want everything that is in between here. All of these could be true. There's also another inequality that has absolute value, and that one is, say, what if the absolute value of x was greater than 2? So again, we see that this is an inequality and it contains absolute value. So we're going to draw our number line again, and we're going to say, okay, well, this is 0, this has to be 2, and this has to be negative 2. Then we want all values of x that are greater than 2 units away from 0. So that would represent all of these answers, and we can take a couple of test points. So say, for example, 3. The absolute value of 3 is 3, and 3 is greater than 2. So this brings up something. This brings up the case that notice that this is a less than statement. This is less than statement. And notice that it produces an and picture. And that is something we studied last Tuesday. It makes an and picture. It's something that's in between. And notice that this symbol is greater than statement. Greater than statement. So, and this creates, this creates an or. Notice that we have either this one or we have this one. So less than statements create and line segments, and greater than statements create or statements on the number line. That's going to be super important in just a second. Okay, make sure you've got all that. Okay. So, for the second box, let's take a look at how we would solve some of these here. So if I had, say, the absolute value of x minus 5 is greater than or equal to 7. So because my inequality is a greater than sign, I know that I'm going to have an or statement. And the way that we set this up is very, very important. Since this is an OR statement, we're going to set this up in one of two ways. So because I have greater than, I'm going to split it off one way or the other. One way is to say that x minus 5 has to be greater than or equal to 7, or I can say x minus 5 has to be less than or equal to negative 7. And the reason I reverse the sign is because I want all things that are less than or equal to a certain number or greater. So, getting back to what we have here. If we have an absolute value inequality that is greater than 7, if it has greater than, we split it off into two separate problems. We say, one, okay, the absolute value of x minus 5 is greater than 7, or we say x minus 5 is less than or equal to negative 7. That's the proper setup. So we're going to call this the proper setup for setting up greater than symbols. Then we simply just solve like we normally would. So we'd say add 5, add 5. So we'd say x is greater than or equal to 12. Or we would say, we would add 5 to both sides, add 5 to both sides. X is less than or equal to negative 2. So when we graphed on the number line, if we were supposed to solve and graph here, we'd say, okay, this must be 0. This is 12. This is negative 2. So we would have all answers going this way because we want all answers that are less than negative 2, or we want all answers that are greater than or equal to 12. So notice that because we had an OR symbol, greater than symbol, we have an OR graph. So that's the proper setup, and that's going to be super important for getting all these problems sort of correct here. And again, the reason we have the greater than is because we have two different directions that we're going here. All right, we're gonna do a less than problem, and then we're gonna do some practice problems. So here we go. We're gonna solve and graph. Solve and graph. So let's do the absolute value. Let's do the absolute value of x minus 5 is less than 10. Now this is different than before. The one we had before was a greater than or equal to sign. This is a less than sign. And we note from up above that if we have a less than sign, then that means we're going to have an and situation. That means that we're going to have two numbers that's sandwiched between. So the way that we set this one up is we say, okay, since it's less than, I'm going to have negative 10. So I take the opposite of what's over here, is less than x minus 5, which is less than positive 10. Now you may be going, well, why the heck did we take the negative? Well, remember, back up here in the top, okay, notice how we had the absolute value of something is less than 2, and we had the negative of 2 because we knew that there were two answers for our absolute value. So that's why we take the negative sign and the positive sign. So I set it up, I say, okay, negative 10 is less than x minus 5, which is less than positive 10. So, and we solve like we normally would. Add 5, just like we would solve a regular inequality. So we would say, okay, negative 5 must be less than x, must be less than 15. So if we're going to graph this on the number line, okay, here is 0, here is positive 15, and here is negative 5. I use two open dots because it's not less than or equal to, and I shade everything in between. Now how can we check to make sure that we did this correct? Well, we could take any test point that's in this shaded region. And so if I pick this point here, which is, I'll call this the point 10. It looks about like 10. If I plug 10 into this equation, it should give me a true statement. So let's see. Is the absolute value of 10 minus 5 less than 10? Well, 10 minus 5 is 5, so the absolute value of 5, is that less than 10? Sure looks like it, because the absolute value of 5 is just 5. And 5 is less than 10, and that is a true statement. Okay, we're going to do some practice problems. I'm going to give you a problem, then pause it, let you guys work it out, and then see if you got the right answer. So here's practice. And we'll just do two of them. Okay, number one. Graph the following. And I'll move it down so that everybody can see. Graph the following. Let's graph the absolute value of y is greater than. Okay, hopefully you've had a little chance to work this out. If not, just pause it right now and come check the answer when you're done. So the absolute value of y is greater than or equal to 3. Well, we have to put 0 on the number line. We have to put 3 on the number line. And we have to put negative 3 on the number line. Just like we would if we had the absolute value of y was equal to 3. We would have these same points. Now, since I want greater than, if I want greater than, I know I'm going to have an or statement. So that means that I'm going to put a dot above 3, color it in because it says greater than. Put a dot above negative 3, color it in because it says greater than. And go out to the left and go out to the right because I want all values that are greater than this. And I could take a test point, any of these test points, and see that that would be correct. Hopefully, everybody got that one right. Okay, number 2. Solve and graph. I'm going to give you the absolute value of x plus 3 is greater than or equal to 7. I'm going to go ahead and pause it. Alright, so hopefully you've had a chance to realize that since this is greater than, this is going to be an or statement. So I'm going to split off into two sections here. This is going to say that x plus 3 is greater than or equal to 7. Or it's going to say that x plus 3 is less than or equal to negative 7. And we solve. So I'd subtract 3. So I'd say that x is greater than or equal to 4. Or I would subtract 3 from both sides. X is less than or equal to negative 11. Or sorry, 10. So on the number line, here's what we have. Okay, if this is 0, and this is negative 10, then that would have to be 4. I'd put an open dot above 10 and 4. Then I would color them in because they are both greater than or equal to. So I would go greater than 4. Or I would go less than negative 10. So how can we make sure that we did this right? Pick any point in this test region. Let's pick the number 10. That's definitely in there. Let's plug this back in. We'll check. Is the absolute value of 10 plus 3 greater than or equal to 7? Sure looks like it. The absolute value of 13 greater than or equal to 7? Yep, 13 is greater than 7. That is a true statement. Let's take a test point in this region, like negative 20. Let's check to see if that one is true. If I take the absolute value of negative 20 plus 3, is that greater than or equal to 7? Well, at first, it doesn't look like it, but remember, absolute value is always positive. So this is going to be the absolute value of negative 17. Is that greater than or equal to 7? Yes, because the absolute value of negative 17 is positive 17, and that, of course, is greater than or equal to 7. And that concludes our video.